Alright, this is the video for a chemical physical changes lab. In order for a chemical change to occur, you have to observe one of these indicators. The first one is a color change, and that's different from a color transfer from things just dissolving. It's like a spontaneous color change when you combine two chemicals. Your next one is a temperature change, and again, this isn't just like heating something up, it's combining chemicals together and they spontaneously change temperature. Next, we have a new smell. This one's self-explanatory. And then light produced, so kind of like if you were to crack a glow stick, it starts producing light. Next, if a gas is produced, you're going to start seeing bubbles, and this is different than boiling something. It's like if you were boiling water, it just goes from liquid H2O to gas H2O. Finally, precipitate forming when you combine things and they become cloudy. So getting started with station 1. So I'm getting my Bunsen burner ready. I want to make sure that my regulator is completely closed, my air inlet's closed, and then I open it 2 full turns. I'm going to get my gas turned on and give it a spark. Open up that air inlet to let more oxygen in. I'm getting a piece of magnesium metal. So you can see what it looks like to begin with. It's a somewhat shiny silvery metal, and I'm going to hold it in the flame. And so if you think this is a chemical change, make sure you write that and also state which pieces or piece of evidence justify that this is a chemical change. All right, with station 2, I'm just going to use my same Bunsen burner flame as before, and this is my piece of zinc that I'm starting out with. And I'm speeding this one up just because this one takes a little while to observe anything. Let's see, not a whole lot is happening. Believe it or not, this is like double speed. So we can see at the end, it has sort of melted a little bit, become a little bit softer. And here's a piece that fully melted. Moving on to station 3. I'm just doing part 1 for station 3, where I'm taking some of this, this acetic acid, which is just vinegar essentially. Gonna get about 5 milliliters of it. Put it into my test tube. And then I'm gonna add a few drops of this universal indicator, which you can see is green to start with. And then it is going to turn a reddish color. Station 4, there's 2 parts here. The first part, I'm getting a piece of chalk. I'm gonna start chopping it up, or grinding it up. As suspected, it is now powdery. And I'm gonna speed up this next step here. Getting about 50 milliliters of vinegar, adding it to our beaker, and dumping the chalk dust in there. So you should be able to hear some of those gas bubbles forming. Next station, number 5. I'm going to start out with some magnesium sulfate solution, about 10 mils or 10 milliliters, and some sodium carbonate. You can see that these are both clear, colorless liquids. And now we're going to combine them in a beaker. And that's what happens after they react. Our next station, station 6. Definitely speeding this one up. It's pretty boring. I just have a beaker half full of tap water, and I'm going to add some iced tea mix, stir it up. It's important to note that this is not a spontaneous color change. It is just a color transfer from the iced tea powder to the water. They have formed a homogeneous mixture. Next, I have some ammonia. This is the stuff that is used like in Windex or a glass cleaner. It is clear and colorless. And then I have some copper 2 sulfate. So that is clear but blue. I'm going to combine them together. can see this has definitely changed its appearance. It is now opaque and cloudy. Station 8. I've got some iodine solution here. You can see it starts out as like a brownish amber color. I'm gonna add a couple drops to a cracker. And then I'm gonna add some distilled water. Station 9, probably the lamest station we have. And I'm just gonna put some distilled water in this beaker and add some table salt or sodium chloride. And I'm gonna mix it up. They can't all be chemical changes, right? Next, station 10. This one's tricky. So we have some acetone. Acetone dissolves a lot of things. And I'm going to put some styrofoam packing peanuts in it. So I know that this looks really dramatic. It is not producing a gas. Basically, styrofoam packing peanuts have a lot of air bubbles in them. And so when the styrofoam dissolves, it's releasing those air bubbles. This is physical. It is just dissolving. It's not a chemical change. That new color you see has just been transferred from the styrofoam packing peanuts. So do not put this as a chemical change. It is physical. This is station 11, and I have these ones sped up as well, but I have some copper 2 chloride. I'm going to measure about 5 milliliters of it in my graduated cylinder, add it to a test tube, and I need to get the initial temperature recording of that copper 2 chloride solution. I'm taking a piece of aluminum foil. I'm going to loosely wad it up, put it inside that test tube, make some observations about what you see here. Sorry for the poor quality here. I'm trying to adjust my tripod. Let's go ahead and get a final temperature for this as well. And this is our last station, station 12. I'm gonna get some distilled water, about 25 milliliters, add it to a beaker, get that initial temperature reading. I'm gonna add a nice big scoop, that wasn't big enough, let's add some more, of urea. And then I'm gonna stir it up with a stirring rod. Okay, and so be sure that you are taking note of that final temperature for this reaction. So once you're all done with this, you can go ahead and submit the Google form. It's going to automatically mark all your observations incorrect because I have to manually grade those, so that will change and I'll return this to you. But you can go back to your previous tab and edit your response. If you got anything wrong and you want to change it from chemical to physical or vice versa. The pieces of evidence, I'm going to be pretty lenient with that just because I know that everybody might have noticed something different, but so I'll go through and look through those and edit those manually. But the two that I'm definitely looking for, you should have at least 2 stations that have a precipitate, so make sure you have those, but otherwise I'm going to be pretty lenient with the rest. So let me know if you have any questions, and I hope you enjoyed this wonderful lab.